Hello and welcome back. We are now starting episode 5 of our series on web services. We've had 4 episodes and we are back for more. Today's episode is a little different from what is usually understood when we talk about web services. The term web services brings up images of requests and responses, fast network communication over the internet, HTTPS for security, and all sorts of other things. But the web service designer needs to do more than just design the interface for the web service. The code that runs inside the system needs to take care of various things. And one of the things we must understand about web services is that studying, analyzing, and debugging a web services based system is more difficult than understanding or debugging a classic old-time batch processing program which runs from the beginning and goes on till the end in one straight line. This is because a web service based application runs a large number of asynchronous small operations. Each web service request coming and hitting my server triggers a little bit of a web service. That web service executes, it does its job, it gives a response and finishes. So the application as we know it is actually not running in a straight line mode, it is running in a completely asynchronous mode, event driven, with potentially thousands or even hundreds of thousands of small pieces being executed in parallelly at random points in a random sequence. Debugging this is impossible. Understanding this is next to impossible unless you have excellent logging. So this episode is basically going to focus on logging. If you want to build a web services based application, you need to build a good logging framework which saves your hide when you get into trouble. So I will cut straight to this product which we built, which is called Log Harbor. It's an open source product. You're free to use it. It will integrate with any business application. Download it from GitHub, set it up, talk to us, go ahead. We have 20 years of experience in just debugging browser-based applications and other challenging scenarios. And we decided instead of telling you what we have learned and telling you what you should do, it might be a better idea for us to do some of it and offer it to the world as an open source product which can be used in any application. So Log Harbor is open source. For us in Remiges, it is mandatory for us to use Log Harbor for logging in all applications we build because we definitely don't want to reinvent the wheel. Log Harbor from day one records 3 types of logs: the debug log, the activity logs, and the data change log. The debug log is basically for developers. As you can see, the audiences are different. Debug log entries are for developers to debug their code. Activity logs tell us what activity, what operation was performed in the system, where, at what time, when, by which user, etc., etc. So activity logs are great for forensics and audits. And data change log is purely for business data change tracking, a kind of audit trail of the values of data inside your database. So these 3 types of logs are maintained separately by Log Harbor under a single common framework. Internally, Log Harbor uses Kafka and Elasticsearch. So the log repositories in Elasticsearch, the streams of log entries are passed from a distributed cluster of servers. If you're running 100 servers, all 100 of them will pump out these log entries which will go to a centralized Elasticsearch database, and the streams of logs are carried over Kafka. So it is a very stable, high performance, well proven set of components which build Log Harbor. And it also has a UI to allow you to browse the log entries when you need to do so. Now, log design is an important part of logging. When we talk about logging, we usually think of logging as software to be written. Oh, we need to write software to do logging. We completely forget that that is a very narrow view of the importance of logging. What is important in logging is the content of the logs. So you have to design that content, just like you design a data structure or you design the content on a web page, you need to design the content of each log entry. So we need to understand what we want to log, which we want to read later, and according to that we need to design our log entries. So look at the goals. Debug logs need to be read by capturing them from a production system without doing a system rebuild. I should not have to switch on debugging and rebuild my software, recompile, relink, reinstall my software in order to switch on debugging, because that defeats the purpose. I need to be able to switch on and switch off debugging in a live system. And it is important that the logs be in a structure and in a format which makes sense to people other than developers. So I should be able to read other people's logs and make sense of them. So once you approach this, once you approach logging with this mindset where you need to design the logging, you need to design not just the software but the logs themselves, then you begin to face these decisions about what will you log, where will you log, which are the points in your software where you will be inserting debug 1 logs and debug 2 logs, etc. If you want to implement a for loop, will you be logging inside the for loop so that every iteration is logged in the logging system? So all of these need to be decided. Then there is this issue of a span. We have talked about a trace ID in the earlier episodes, where when there is a call from an external entity to a web service, every call has a unique trace ID. Internally, for server to server communication or module to module communication, we also have a span ID, which tracks subdivisions of a trace. So while trace gives you the bigger picture, the span gives you fragments of that bigger picture. So where will you start a new span? Because the span will be logged in your logging system. So you need to evolve your own standards for your teams, which must not be confined to one project. These standards must be cross-project because these standards apply to any business application. And the standards need to be specified as in writing. One of the most important aspects of logging is the viewing of the logs. See, it is very easy for us to build a logging system where logs are being dumped into some database table and millions or billions of log entries are being accumulated. Good, great. But if I can't view the logs, is it of any use? If I can't view them in a meaningful way, in an easily searchable way, there is no point in acquiring those logs, right? So we need to have a viewer which lets us view 3 types of logs, all 3 of them, because first of all, the users of this log viewer will be your own developers. We have to understand that log files are gone. See, there was a time when you would set up a server, and that server would be set up and running your software for the next 5 years or 10 years. That server would not change. New servers would not be born and killed in a matter of minutes or in a matter of hours. So a server was a sort of static, stable entity, and the disk space, the file system of the server would be where you would write your logs. And you usually had a small number of servers, 2 servers, 5 servers, etc. That era is gone because applications run in containers. And containers are created and destroyed in a matter of minutes, depending upon system load. Therefore, it is difficult for container-based software to write log files in a place where you can easily find them. So you can write logs in a shared drive, but that kills performance. So you have to log over the network. The only way a modern logging system can work is if it has distributed clients and can log from 10 servers or 100 servers all into a central repository, which is what Log Harbor does. But if it does that, you need a viewer. If you don't have a viewer, how do you see the logs? Because you're no longer able to open a log file in an editor and scan through the lines. So because of these reasons, a viewer is extremely important, and it has to be built for your logging system on day one. If you're using Log Harbor, you have a viewer straight away. Now, if you look at the what is there to view in a log, then you find different types of things. If you look at the data change history of your application, you will find the data change history for one object or also for one field of an object. So you can actually do field by field tracing to see how values of a particular field of a particular object have changed with time. If you want to trace activities, you can trace all the activities which have hit one object, for instance, one bank account or one voucher or one loan application or one share or one type of security or share which is being processed. So you can see all the activities for that object, you can see all the activities done by a user. So what has the user been doing the last 7 days? Activity logs are a very easy way for you to see a full trace of activities in these two views. You may also then drill down and find out from where accesses are coming to your web services, and you can collate a list of rare IP address from which accesses are coming. This could be a potential security warning system. If you pull out the rare IP addresses from which activities are being performed, you may find that they are not above board. It is always possible. That's a line of investigation. High priority events are another thing which you may easily pull out from the logs, because if you just filter on the priority, you will be able to get the entries which are high priority. Then you look for system health related log entries. What is happening in authentication failures? What is happening where people are trying to access an operation for which they are not entitled? How often do these things happen? From where do they happen? Then rate throttling events. Are you seeing signs that web services are being triggered too often and therefore the system is throttling the accesses? Now all of these will go into logs, and if you pull these out and go through them, you will be able to get interesting insights into your system health. So logs are a must. Logs are the only way you can hope to understand what your software is actually doing in a production environment. And for that, you need types of logs, you need a robust log capturing infrastructure, which we have built using Kafka and Elasticsearch, and you need viewers to view the logs. Debug logs are well understood. So these are what you need to get out of your logging system. Thank you. This was a short, sweet episode. We are at the end of this episode, and we will see you again, hopefully, in the next episode when it starts. Have fun writing web services.